We use the idea of limits in maths to try to determine what is going to happen to the y value of a function as its x value approaches a particular value. In this example here, we want to know what's going to happen to this function when x gets closer and closer to 3. Now, we're going to do this from two different directions. I'm going to start here and move down our function to this point. And as x is getting closer and closer to these 3, we can see our y values getting closer and closer, and eventually our y values get to there, and we can say that it equals 2. Now, this may seem fairly straightforward and obvious to you, but just bear with me here. The way I can express this is I can write the limit as x approaches 3, and I'm going to write down the plus sign there. That says that it's approaching it from the positive direction, this side here. So the limit as x approaches 3 of this function, whatever that function is, equals 2. Now I'm going to do the exact same thing, but I'm going to come up from this direction. I'm going to come up from the negative side. And you can see the same thing. Our y values are getting closer and closer and closer to 2, which they end up reaching right here. So now from this, I can say the limit as x approaches 3 from the negative direction of this function equals 2. And because these both equal the same number, because when we approach it from the positive direction we get 2, and when we approach it from the negative direction we get 2, we can say that the limit exists. And this is actually going to become very, very important when we're doing our calculus, because we can only obtain the derivative of a function if the limit exists at that particular point. Now, you might be thinking to yourself, what type of function is there where a limit doesn't exist? Well, I'll give you a very quick example. You might have a function that comes up to here and then goes off in that direction. So we've got a bit of a split in our function. We call that discontinuous. And we'll say that that's 3, that's 1, and that's 2. So now if we're trying to calculate the limit, we'll go from the positive direction. As we come down our function from here, approaching x equals 2, we're going to see that the limit gets close here. It gets to the number 3. So I'm going to write down the limit as x approaches 2 from the positive direction of this function equals 3. But if we try to do this from the negative direction and we try to come up here, we're going to get to a different value. As x gets closer to 2, y is going to equal the number 1. So I'm going to write down for that the limit as x approaches 2 from the negative direction of f of x equals 1. Now, because those two values don't equal each other, you guys should know this, the number 3 and the number 1 are not the same number. Because they don't equal each other, we have to say that at that point, at the point x equals 2, the limit does not exist. Which means that we are not actually going to be able to calculate the derivative of this function at that point, x equals 2. We can figure it out for x equals 2.1, 2.01, 1.9, 1.99, all of those values, but at x equals 2 specifically, there's nothing we can do with the derivative.